All right, everybody. Good morning to you. Sorry for the late start. The mouse was not working here. Let me see if I can get this going here. I don't know if it's not charged, and I was charging it. So, anyway, um, okay. So let's see what we can do. So, ladies and gentlemen, I want you guys to warm up today because today we're going to talk about what's called the sequential solutions. So I want you guys to take a look at this here. This is the particular solution over a restricted domain, okay? So let's see if our audio is on. So this domain is restricted from 0 to what? 2 pi. You guys know what I mean? So you have a restricted domain here. So I'm going to go over, I'm going to ask you guys this morning to write this in terms of the general solution, because last time we went over the general what? Solution. So today I want you to do that as a quick warm up if you can. Just take a few minutes to do that and let's see what you get. And I'll give you guys a few minutes as I try to get this, see what's going on with this mouse. Okay. Alrighty. Okay, ladies and gentlemen, let's try this out. Do you guys remember how we did this last time? How did we do this last time? That first solution here, so we guys want to determine the general solution here. We're going to reference this first solution here. This is going to be pi over 6, which is 30 degrees. Is that right? Okay, so what do I mean by the general solution here? We want every coterminal solution, right? So all solutions that are coterminal. And so what does coterminal mean? Well, they share the same what? Terminal point. That's the terminal point, okay? So what I'm going to do is I'm going to rotate this how? 1 revolution counterclockwise, 2 revolutions counterclockwise. Oop, went too much. 3 revolutions counterclockwise, right? I can go the other direction, 1 full rev. Another full rev. And here you go, ladies and gentlemen. So what you're going to have now would be pi over 6 now plus what? 2n pi. Because this is the portion that we're talking about here. This is that we say the n revolutions here. N revs. And this will give you every coterminal solution. Okay, so far so good. You guys okay with that? Easy peasy lemon squeezy? So you say, okay, that's the first one. What about, and we can call that theta 1 now. What about the second one? You say, how do we start here? We start at what? 5 pi over 6? And what was 5 pi over 6? You guys remember? Was that 5 times 30 is 150. There you go. So let me go back here really quick, and here's the terminal point. So if I rotate this here now, how many? 1 rev, 2 revs, counterclockwise, 3 revs. Okay, went too far. The other direction, 1 full rev. Okay, you guys remember that? So what do I do now with this? I take the particular solution, which is what? And then what do I add? 2n pi for the same reasons. Is that true? This is the n revolutions that gives you every coterminal solution here. And that's what we're doing here. Now, what is n? What do we say n was last time? N, we have to write this down too. What is n? See this n? Here's our n. Here's our n. Here's our n. These are the n revs. What does n have to be? N's an integer. So we want to write the phrase down. N is an integer, where these are the integer values. So let's take a deep dive here on this. There's a deep dive. N is an integer. And here we go, ladies and gentlemen. Easy peasy lemon what? Lemon squeezy. Okay, what do you guys think? Now, I should title this here. This is going to be what you care about today, all right? We wrote this as a general solution here. I'm going to kind of remark now. Let me go through every one of these here. Let's try it out together so you guys are aware. Let's try the next one. General solution here. Okay, now notice the first solution is theta 1 here, right? Which is pi over 2 now. So how do I get the general solution for theta 1? We start with the particular solution of pi over 2 And then what do we notice about this? If this is our terminal point, what do? Rotate what? 1 revolution, 2 revolutions, 3 revolutions. Go the other direction. 1 rev, 2 revs, 3 revs. What do you think we do now? How do we get every coterminal solution? What do you guys think? What do we do? Yes, you're going to add that 2n pi again. I'm going to change colors. Huh? That's a very good question. You say, how do we know the number of revolutions? Well, you know what? This is general. This means n revolutions. So we can do this forever. You go, what does n need to be? N needs to be a what? What does n have to be? An integer. So what this means here is that we can get every solution imaginable forever. N is an integer because the integers, again, are these numbers right in here. And we're going to look at how to do this, okay? We're going to look at some details with this today. So I just want to kind of remark today here, we're going to warm up by getting general solutions, and then we're going to talk a little bit more detail for why you care about that. It's related to your question, but n must be a what? Integer value. Yeah, we're going to see some of those details. Okay, but the idea is to have every coterminal solution. Now, look at theta 2 now. You say, how do I handle theta 2? Well, what is theta 2, right? I wanted to share with you guys these pictures because a picture is worth 1,000 what? Words. So the second solution here would be pi over 4, right? 45 degrees. And what do you guys notice about the third solution? It's 5 pi over 4. Aren't these directly what? These are directly opposite. They're not just in opposite quadrants. What are they? These are directly opposite. Directly opposite means, if you guys remember, that they differ by what? 180 degrees. Is that true? So when they differ by 180 degrees, what do? Do you guys remember? You take the first solution, which is pi over 4 up here. You take this first one, it's pi over 4, 45 degrees. And instead of adding 2n pi, what are you guys going to add? N pi. Yes, you add n pi, where n again is a what? Is an integer. Now, you say, why would I do this? Because now I don't have to go to the third angle. I get the third angle free of charge. It'll be pi over 4, and then if I change my n value, I'll get 5 pi over 4. We're going to see some more details with this today, but this is getting the general solution here. But I want to emphasize, again, if you have opposite quadrants, meaning directly opposite, emphasize that if you look in back of the book, this is going to be pi. Now, let's take a look at this one here. You guys ready? How do you think we do this one? We have 3 solutions here, okay? So if I start with the first solution here, what's the first solution? What's our theta? Theta 1 is 0. What do? You take 0 and I do what? And I add what? 2n pi. Why do I add 2n pi? If this is my terminal point, how would I get every other coterminal solutions. I have to rotate how? One full revolution, 360 degrees are 2 pi radians, right? And I could do this forever. So theta 1 means it's 2n pi, where n is an what? Integer. All right, you guys okay with that? So take your 0 and do your arithmetic and add it with 2n pi. You get 2n pi. What about theta 2, ladies and gentlemen? What do you think? For theta 2, don't you do the same thing? Okay. Here's that terminal point. So how are you going to get every solution? You rotate what? 360 degrees. So theta 2 is going to be what? Pi over 2 plus what? 2n pi. So here's going to be our n what? N revolutions, right? Full revolutions. Easy peasy lemon squeezy. Here we go. Terminal point. So you start with a particular solution. How do I get every coterminal solution? You rotate what? In any direction, one full revolution. So to get every coterminal solution, that's n revolutions, you're going to have to add the multiple of what? 2n pi. You guys okay with that? All right, you guys hear me on that one? Oops. Did I make a mistake? I think I skipped one. No, I didn't. I just call it theta 2, and it's really theta 3. I apologize. So, ladies and gentlemen, we have here again the general solutions, and hopefully this helps you guys out. And that's an extremely important detail. These are all our general solutions. Okay, you guys okay with that one? Easy peasy lemon squeezy? Now, let's make it interesting. What do you guys think about this one? Interesting. Okay, you guys okay with that one? Should we give you guys some time to try this one out yourself? Let's give you guys some time here. I'm going to give you guys some time. Let's see what you can do. All right, ladies and gentlemen, let's try this out. What'd you guys do for the first general solution here? Huh? What's theta 1? Pi over 4. What's this? Plus. What is this? That differs by pi. Is that right? So you're going to put n pi. So that what that means is you're going to get this first solution and even what? Second solution. Because they are in directly opposite quadrants. Is that right? Good job. How did you get the second solution here? Same way. In other words, start here with 3 pi over 4. You are correct. And then what do? Since that differs with the opposite quadrant as well, by pi, you're going to simply add what? N pi. And what does n have to be? N is an integer. Good job. And so, ladies and gentlemen, there's only these two ways to describe this. Okay? Easy peasy lemon squeezy. All right. Now, here's the thing here for you guys. I'm going to do this here. We're going to talk about some details now here about what is this n being an integer? How does it really work? Okay? And sometimes what they'll describe to you here, if you read the book, right, and you go, okay, I worked on some homework. Let's go back to this first one. And they may say, hey, what is this sequential form? We have something called a sequential form. And why do we have to have that, right? Sequential form. That's a cue. Sequential solution, sequential form, I don't know. What does that mean? You got to write it as a sequence. Your solutions get written as a sequence. We're going to express to you why they want to do that, right? They might say to you, can you write the first 5 solutions? You know, they may say, what are the first 5 solutions? Right? They might, I'll put that language over here. They want the first 5 solutions here. You're like, what are you talking about? How do I get the first 5? What do they really mean? We'll figure this out, okay? Well, we're going to write this in sequential form. Now, sequential form is really simple to do. You kind of already have the process. I'm going to say start with the general solution here, right? You see this here? So I'm going to get rid of this. This is kind of in the way. All right, so I'm going to start with this first solution. And I want you guys to notice here, there's arithmetic here. You guys okay with that? So how would I add a whole number like maybe pi over, a whole number like maybe the 2n pi revs with a fraction of pi over 6? That's what you're doing. You're doing arithmetic with a whole number and a what? Fraction. You guys okay with that? So I'm saying, take a look at this arithmetic. Pi over 6 plus 2n pi. So down here, I'm going to do a little bit of arithmetic. Do you guys know how to add pi over 6 plus 2n pi? What would you do? Don't you need the same denominator? So put this over 1, multiply the top by 6 and the bottom by 6, okay? You say, why 6? Because you're taking a fraction adding it with a whole number. And now you end up with what? Pi over 6 plus 12 in pi over 6. So what is pi over 6 plus 12 in pi over 6? What do you got? Well, be careful here. It's not 13 pi over 6. Right? You're going to get what? Oh, I think you get pi plus what? 12 in pi over what? 6? Well, how about this? We're going to do something a little bit different at this point. Don't add those here. Okay? Don't add. Okay? Let's leave it at this. Yes, we're adding, but we're going to leave it like this here. What I want you guys to know to do here is, I'm going to try to find a nice color, maybe pink. You see that fraction, pi over 6? Don't add. See the pi over 6 there? I want you guys to factor that out. Factor out this common term in pink. Factor out your pi over 6. And you say, well, what is that? Well, it's pi over 6, ladies and gentlemen. Pi over 6 times what? Right? We're going to factor out the common pi over 6. What you're going to have left here, when you factor that out, think of there being a 1 here. And you got 12n. So you're going to end up here with this 1 plus what? 12n, because you are factoring out the pi over 6 multiple. So don't really add, just factor that part out. You have now, this is called the sequential form. It'll be pi over 6 now times 1 plus what? 12n. Okay? So I'm going to erase this up here and write down the sequential form. It's the factor of pi over 6 times 1 plus 12n, where n still is the same n is an integer value. Okay? So here's the arithmetic on that. Arithmetic is down here. Now, you might say, well, why do I care about that kind of arithmetic? Let me go over the detail for why you care. Okay, this is the sequential form now, not the general solution. It's kind of a form of the general solution. You might say, why do they call it a sequence? Well, what does n have to be? N is an integer value. N is one of these numbers here. So if I have to find solutions now there for that one, and they say, what's the first 5 solutions? Well, what I would do now is I would say, okay, I'm going to start with n equal to 0, and I plug in 0 here. What is 12 times 0? Isn't that 0? What's 0 plus 1? So what that means is the first solution for theta, or the angle, is that original pi over 6. It's that particular solution here. That's the first one. And that corresponds with n being 0. And so you say, well, how do I get another solution? Well, change the value of n. Let n be now what? 1. So if n now is 1, go in and plug in what? 1. So what's 1 now? What's 12 times 1? 12. What's 1 plus 12? 13. You know what the second solution could be? What's that going to be? 13 pi over what? 6. So all you have to do now is change your value of n. Now n will be 2 here, and you do that arithmetic. What is now, if n is 2, what's 12 times 2? 24 plus 1 is 25. So the next solution will be 25 pi over 6. There's the next solution. 25 pi over 6. Okay, now those are two solutions. Even though they said, what's the first 5? Well, then you could say, well, do I have to do n is what, 4 now? Okay, if n is 4, what do you get for theta? Just plug in what now? The next value for n will be 3, and do your arithmetic. What's 12 times 3? Isn't that 36? And then 36 plus 1 is 37. And so you're going to end up with here 37 pi over 6 as a solution. That's another solution here when n is 4. What do you get now when n is 5 now? Well, not n is 5, n is 4. We skipped 3. We wrote down, there we go, this was 3. Now we got to do 4, not n is 5. So now n is 4. So plug in that 4 now. What's 4 now times that 12? What do you guys get? Isn't that 48 plus 1? And what does that give you? 49 pi over 6. So ladies and gentlemen, all of these are the solutions for that first theta being pi over 6. These are all the coterminal solutions by just changing the value there of what? N. Yeah, it goes on forever. You say, what do you mean? This goes on. You see the 3 dots? It goes on forever. Infinitely many solutions. 3 dots go on forever. Now here, you say, what is n here? N's going to be what? -1 now. So when n is -1, we say theta will be what? Plug in -1 now for n. That's why you have that nice value here. So you do the arithmetic of 1 plus 12, or I should say now 1 minus 12, because 12 times -1 is -12. Is that right? And what's 1 minus 12? Isn't that -11? So I'm going to put it up here. Say that will be -11 pi over what? 6. Just by changing that value here. -2. So if n is -2, what's 12 times -2? -24. What's -24 plus 1? It's -23. So we get -23 what? Pi over 6. So there you go, ladies and gentlemen. -11 pi over 6 and -23 pi over 6. These are all the different values of n. And this is why we call this the what? Sequential solution here. Because you can now generate very easily by doing some arithmetic the values of n. This is the sequence version. So this is in your book and you say, hey, Mr. Judge, you never talked about that sequential form. How do they get these other solutions? Well, that's how you do it. You really aren't getting other solutions. You're getting the coterminal solutions very easily by doing a little bit of some arithmetic and algebra there. And that's actually the preferred form, if you guys want to know, in my opinion, the sequential form. Well, in the book, they use not n, but they could use k, where k is an integer. So sometimes they say k is an integer, not n is an integer. It doesn't matter. J is an integer. It doesn't matter. Integers are all, when they say they're an integer, this is what they're saying, those numbers here. 0, 1, 2, 3. These are all the values of n or k or j that you talk about. And you could do this forever. N could be -1, -2, -3. Hopefully they tell you where to stop, right? You go, where do I stop? They tell you. Okay, you guys okay with that? Easy peasy? So I'm going to erase this. It's in your notes. Because what if they said to you now, hey, can you give me the general what? Sorry, the sequential solution for the other form. Remember, there was 2. What if it started with 5 pi over 6? Right? You got 5 pi over 6 plus 2n pi. We got to write that in sequential form. So it's the same exact kind of process. We'll say, okay, you take the fraction of 5 pi over 6. We add it with what? 2n pi. So you said, what do I do? Well, here's what you do. Multiply the top by 6, the bottom by, divide by 6 down the bottom. You now get what? 5 pi over 6 plus, what's 6 times 2n pi? Isn't that what? 12n pi, and that's over 6. You guys okay with this? Bless you. Right? Isn't that what we did before? All right, now what else did we do before? We took that multiple of pi over 6. You see that there? And what did we do last time? We factored that out, right? Factor out pi over 6. So that looks like this. You take what? Pi over 6 times 5 plus what? 12n. So this is going to be your replacement for your general solution. This is now a sequential solution. It's really part of the general form. So now you can generate very easily with some arithmetic all your solutions here. Or you can generate some solutions by changing the n value. So just change your n value, and ladies and gentlemen, you're going to be able to do what? Yeah, you're doing like a sequence of solutions. Okay, so n here is going to be a what again? An integer. Okay, so I'm going to erase this. It's in your notes, it's in the video. Factor out that multiple of pi over 6 again, and you're going to get this version. Now you say, well, how do I use this? Well, you can start with n equals 0. And if I plug in 0 now, right, maybe I plug in 0 up here, you might be more interested in this arithmetic. You say, I don't know. Okay, 5 times, what's 12 times 0? What's 5 plus 0? 5. So then what's 5 times pi over 6? 5 pi over 6. That's exactly what you had up here. So you always start with that particular value when n is 0. It'll always happen. So this is how we get the 5 pi over 6. And when you say, well, what happens if your n value now is 1? What would theta be when n is 1? Okay? Well, just replace this what? Replace 1 with n. N is a nice integer. And then do your arithmetic. So what is your arithmetic here? This is what? 5 plus, what's 12 times 1? What's 5 plus 12? 17 pi over what? 6. Okay, you guys okay with the arithmetic? Happens now when n is 2. What's 2 times 12? Is that 24? Well, then what's 5 plus 24? 29. So you say, okay, this will be what now? 29 pi over what? 6. So I can generate solutions here. Change n. N will be what? Negative 1. If n is negative 1, what's 5 now? What's 12 times negative 1? Isn't that going to be minus what now? What's 5 minus 12? Negative 7 pi over what? 6. N is negative 2. So 12 times negative 2 would be negative what? 24. What's 5 minus 24? It's negative 19 pi over what? 6. All of these are what? What you need. Easy peasy lemon what? Squeezy. Just change your n values. Change your integer values because they're called integers. And you could generate solutions all day what? Long. This is the sequential form, how you do this. Okay, you guys okay with that? Sequential. So, you know, what I want to do here is help you with the arithmetic or the algebra. Let's write these in sequential form. What do you guys think? Okay? So I'm going to erase all of that. Let's get rid of that highlighter. Let's write this in sequential form. So you might say, how, right? Well, we're going to take this over here, pi plus 2 plus 2n pi now. So let's do the arithmetic. Write this in sequential form. Sequential form. Write it as a sequence. What's your denominator here? 2? What do? Write the top times 2, the bottom times 2. That's 4n pi over what? Over 2. All right, you guys okay with that? Now again, take the what? Take this pi over 2 here. Factor that out. Let's say factor out the pi over 2. So you say, well, what does that mean? You're going to write it as pi over 2 times, here's my parentheses. Put a 1 here. Say there's a 1 and there's a 4n. You guys okay with that? So it'll be 1 plus what? 4n. So that will always be the case. So if colors help you, ladies and gentlemen, that first sequential form of a solution would be theta 1 becomes pi over 2 times 1 plus what? 4n.
Where's the 1 come from?
Well, 1 times anything is itself, so you need a number there to factor that out. There'll be a 1 there. Okay, you guys okay with that? So we can change this one. And see, there you go. This is the sequential form. Let's do the next one. Let's go through the process, right? You take what? Pi over 4 plus what? N pi. Okay. So you have this 4 now. Multiply the top by 4, the bottom by 4, and you get now what? Pi over 4 plus what? 4n pi over 4. So you're going to make sure now you factor out the what? Pi over 4, is that right? And I think, what happened here? Uh-oh, something's, okay, no, something's right. Okay, everything's okay. So we're kind of very similar here in the sense that, what is this here? There's a 1, is that right? So you take out your pi over 4, and that's 1 plus now what? 4n. So this is very similar. That's what got me, is that was very similar. This is pi over 4, 1 plus 4n. So pi over 4, 1 plus 4n here. Here's a sequential form. Okay, you guys okay with that? There it is. This is the sequential form here. Easy peasy, lemon what? Squeezy. Let's try this with these. What do you guys think? What do you guys notice about that first solution? It's already in what? Sequential form, that first solution. So they're going to want you to write this in sequential form as well. And that's already there. Two n pi. Let n be 0. Let n be 1. Let n be 2. Let n be 3. Let n be -1. It's already there. Now, pi over 2 plus 2n pi. Let's do this arithmetic. Put this over 1 and then do what? Multiply the top by 2 and the bottom by 2. Pi over 2 plus 4 pi over 2. Pi over 2, pi over 2. Factor that out just like before. Put your 1 there. You guys okay with that? Pi over 2, 1 plus 4n. So n pi over 6 plus 2n pi. 2n pi over 1. And then down here you got a 6. And what do you guys do now? 6, 6. What do you end up with? 7 pi over 6 plus 12n pi over 6. Factor out your what? Pi over 6. What do you have left? 7 plus what? 12n. So you get your pi over 6, 7 plus n pi. So see if you guys can appreciate the colors. What do you guys think? There you go. Okay. Let's try this here. Okay, we're going to try to write the sequential form for these. So you're gonna, for these here, you can do sequential form. Pi over 4 plus n pi. So you're going to multiply the top by what? 4, the bottom by 4. You have pi over 4 plus what? 4 pi over 4. So put your 1 there and factor out your what? Pi over 4. So you get your pi over 4, and then the 1 plus what? 4n. Easy peasy lemon squeezy. So this is the first general solution. So we're going to do the same over here with the what? 3 pi over 4 plus the n pi. We're going to take this general solution. We're going to write it in sequential form. Okay, you okay with that? Okay, so let's do this again. This is going to be over 1. We're going to start by doing kind of the arithmetic. 4, multiply the top by 4 and the bottom by 4. Okay, so pi over 4, 3 plus 4n. So, ladies and gentlemen, here's the last one. Pi over 4 now. 3 plus 4n. So, ladies and gentlemen, n is your integer value. This is now in what? Sequential form. And this is the arithmetic or the algebra that's used to write this all in sequential what form here. Easy peasy, what? Lemon squeezy. So, ladies and gentlemen, I hope this helps you complete your homework. Does that help a lot? All right. Well, we'll see you guys later. Take care. Have a great day and stay safe.